Welcome to another Python Pygame tutorial. Today, we dissect the iconic snake game developed with Python's Pygame. Together, we'll dive into its classes, methods, and constants to unveil the magic beneath. The code you're seeing on screen is organized using object-oriented principles, splitting our game into logical sections for the snake, the food, and the game itself. Let's dive into it. Starting off, we import Pygame and import random. These are the backbone libraries that power our game's functionality. Our first step is to initialize Pygame using Pygame init. This preps the Pygame module for action, ensuring all the functionalities work seamlessly. Next, colors are visual anchors. Constants like white, green, and red encapsulate the RGB values. They represent our game's palette, determining the shades of our snake, food, and scores. For our game canvas, we have predefined dimensions: screen width, screen height, and the cell size. Together, they sculpt the gameplay's visual boundaries. The essence of the snake game is its movement. Up, down, left, and right aren't just directions, they're tuples. They dictate how our snake will reposition in the grid. Behold, the protagonist of our game, the snake class. This class is brimming with methods that dictate the snake's behavior. Every hero has an origin. For our snake, the init method initializes its starting size and direction. Here, the snake starts as a sequence of coordinates, progressing rightwards, hungry to grow. The move method is where the action happens. By recalculating the head's position and considering the current direction, our snake embarks on its journey. Notice how it wraps around the screen? That's due to the modulo operation. But wait, what if the snake bites itself? That check, right there, determines if the new head's position is already occupied by the snake. If it is, well, game over. Now, for every food consumed, our snake desires to stretch. The grow snake method sets a flag, letting the snake expand during its next move. Pivoting is vital. With change direction method, the player steers the snake. It's coded intelligently to prevent the snake from reversing into itself, preserving the game's fluidity. One of the foundational blocks of any visual game is rendering its components. The draw method in the snake class does precisely that for our slithering hero. Within this method, a for loop iterates over each segment of the snake's body. For each segment, a green rectangle representing a piece of the snake is painted onto the screen using Pygame, draw, rect. The arguments? The screen, our snake's color, green, and the coordinates, all calculated using our consistent cell size. Hungry for more? The food class feeds our game, both literally and programmatically. The food's position is randomly decided using the randomized position method. The food class also houses its own draw method, ensuring the food's representation on our game canvas. Behold this simplistic beauty. Just like our snake, the food's position is converted into pixel coordinates and painted onto the screen. This time, though, it radiates in a tempting red, drawing both our snake and players towards it. The director of our gameplay drama is the game class. Orchestrating snake movement, collisions, scores, levels, and the overall rhythm, it's the nerve center of our game. The drama unfolds with check collision. Every time our snake approaches food, this method checks for a meetup. If they do, the snake grows, scores are updated, and occasionally, the gameplay difficulty is bumped up. Mastery should be rewarded. Hence, the level up method increases the game's tempo, accelerating the snake's movement and enhancing player engagement. At the heart of it all, the run method is our game's pulse. It's an endless loop of events, checking player inputs, updating snake's position, rendering the game visuals, and more. It's where the player's actions, game's logic, and visual cues intertwine. The culmination of our code is this main block. Setting the stage, it initializes the display and kickstarts our game loop. Every interaction, be it the snake munching food or slithering across, is a result of this block. If you were to ponder, when are these draw methods invoked? Dive into the depths of the run method. Amidst the gameplay loop, after every logic calculation and before updating the display, our snake and food are artistically rendered frame by frame, bringing our game to life. So, with all these intricacies explained, why just read when we can play? Observe the dance of logic and visuals as the snake pursues its never-ending quest for food. Every pixel you see, every movement you witness, has a story. A tale of methods, classes, and constants working in harmony. It's the beauty of coding unveiled. Thanks for embarking on this code journey. Dive deeper, experiment, and remember, in the world of coding, every line has a tale waiting to be told. Happy coding!